Hello students, welcome to JCE Connect, subject groundwater and hydraulics. In today's class, we will discuss few more definitions. So the first one is hydraulic conductivity. So for practical work in groundwater hydrology, where water is the prevailing fluid, the hydraulic conductivity K is employed. So here for groundwater studies, the value of hydraulic conductivity is very important. Okay. So the medium or a medium is a soil or any type of material through which the water is passing. So a medium has a unit hydraulic conductivity. So the medium through which the water is passing, it will have a unit hydraulic conductivity when if it will transmit in unit time a unit volume of groundwater at the prevailing kinematic viscosity through a cross section of unit area, and it is measured at right angles to the direction of the flow under a unit hydraulic gradient. So that is the definition of hydraulic conductivity. So what is mean by hydraulic conductivity is, the hydraulic conductivity is a medium will have a unit hydraulic conductivity when if it will transmit in unit time a unit volume of groundwater at the prevailing kinematic viscosity through a cross section of unit area, and it is measured at right angle to the direction of the flow under unit hydraulic gradient. So that is called as the hydraulic conductivity. So if you talk in terms of formula, okay, capital K is the symbol for hydraulic conductivity. Okay, K is the symbol for hydraulic conductivity. So K is given by V, that is the velocity, okay, and divided by dH by dl, that is the hydraulic gradient. Okay, dH by dl stands for the hydraulic gradient. So here hydraulic gradient is what? The change in the total head divided by the distance over which the change occurs, that is called as the hydraulic gradient. So here the unit of this becomes V, that is the velocity, that is in meter per day, and dH by dl is meter. Okay, so meter per meter, that dH, this is the distance, okay, distance over which the change occurs. So the final unit of K, that is the hydraulic conductivity, that becomes the meter per day. Meter per day is the unit of hydraulic conductivity. And here a meter per day, that indicates the hydraulic conductivity has the unit of velocity. So both hydraulic conductivity and the velocity, they have the same unit, that is meter per day. Here one more point to discuss is kinematic viscosity. So here kinematic viscosity means it equals to the dynamic viscosity divided by the fluid density, that is called as the kinematic viscosity. So what is the definition of hydraulic conductivity, which is very important. So the medium has a unit hydraulic conductivity if it transmits in unit time a unit volume of groundwater at the prevailing kinematic viscosity through a cross section of unit area, which is measured at right angle to the direction of flow under a unit hydraulic gradient. So this definition is very important. Now determination of hydraulic conductivity is also important. How to determine the hydraulic conductivity of an aquifer? Okay, so there are various methods. So before dealing with those methods, we will see few more definitions. The next definition is, what is intrinsic permeability? So we have discussed what is permeability. The permeability is a property where the water, the ease with which the water can flow through the medium, it may be a soil or any other material. So at what ease, okay, what ease the water will flow through the medium, that is called as permeability. So the permeability of a rock or a soil defines its ability to transmit a fluid, right? Through the pores the water will transmit, it will move from one place to other place, so that movement is called as the permeability. So this is a property only of the medium, and it is independent of the fluid properties. Okay, it is, the permeability is the property of the material through which the water is flowing. Here the properties of water will not be affected much. So to avoid the confusion with hydraulic conductivity, which includes the properties of groundwater also, right? We have discussed here what is mean by hydraulic conductivity. And intrinsic permeability is expressed to avoid the confusion between the hydraulic conductivity. There is one more definition called intrinsic permeability. So what is that intrinsic permeability? So that is expressed as K is equal to, that is small k, you can see the symbol, capital K represents the hydraulic conductivity, whereas small k represents the intrinsic permeability. So here K is equal to capital K mu divided by rho g. So what is these all formulas, where K stands for the hydraulic conductivity, that is capital K. Then mu, what is mu? Mu here is the dynamic viscosity, and rho is the density of the fluid, here it is water in case of groundwater, and g is the acceleration of gravity. So this is called as the intrinsic permeability. So this intrinsic permeability, okay, if you insert this in the previous equation which we have solved, okay, that is K is equal to capital K, if you replace, right, that is the hydraulic conductivity. If you replace this K by what is the formula? K is what? Minus, okay, hydraulic conductivity, capital K is equal to what? Minus, okay, what we have discussed, minus V divided by dH by dL. Okay, so that is what? The hydraulic conductivity. Now if you replace this K by this, okay, what you will get? So here you will get it as small k, that is intrinsic permeability. Intrinsic permeability is equal to mu will remain as it is, and will replace K by minus, you can see, minus V dH by dL, that is nothing but the capital K, and denominator, that is rho g, remains as it is. Okay. So if you write the units of all these, okay, what is the unit of mu? Mu is the dynamic viscosity, that is kg per meter per second, right? And V, okay, so here V, the velocity, that is meter per second, and rho is the density of the fluid, has the unit of kg per meter cube, and then g that is acceleration due to gravity, that is meter per second square. Okay, and dh by dl is m by m. Okay, so if you calculate all these, if you solve, you will get the unit of intrinsic permeability as meter square. Okay, the unit of the intrinsic permeability as meter square. So meter square is the unit of area, right? So thus we can conclude that the intrinsic permeability has the unit of area, that is meter square. Okay, so this definition and the unit is very, very important. Next, we'll see one more definition called transmissivity. So the symbol for transmissivity is the capital T. So here the transmissivity is widely again used or employed in the groundwater hydraulics, and it is defined as the rate at which the water of prevailing kinematic viscosity is transmitted through a unit width of aquifer under unit hydraulic gradient. So that is the definition of transmissivity. So what it says, transmissivity is what? It is defined as the rate. Okay, it is the, see, the word itself tells you transmissivity means water is transferred from one place to other place. So it is what? It is the rate, right? So the rate at which the water of the prevailing kinematic viscosity is transmitted, right? So here transmissivity refers to what? The water is getting transferred from one place to other place. So that is, and which has a prevailing kinematic viscosity. Okay, and it is transmitted through a unit width of aquifer under unit hydraulic gradient. So the formula for T, that is transmissivity, is K into B. K is nothing but the hydraulic conductivity, right? Capital K, which is nothing but the minus V dH by dl, V divided by dH by dl, right? So into B is what? The aquifer thickness of the aquifer which is saturated with the water. So here you can define transmissivity as the product of K and B. Okay, where K is the hydraulic conductivity and B is the saturated thickness of the aquifer. So if you write the units of all these, K is meter per day, and B, that is the thickness, it is meter. So if you solve this, you will get the unit as meter square per day. So that is the unit of transmissivity, that is T. The symbol is capital T. Okay, so these all definitions are very, very important from exam point of view. Thank you.